Hi, welcome. In this video, we will solve problem container with most water asked by companies like Amazon, Microsoft, Apple, and Google. Let's check out this one of the most famous question container with most water. So you are given an integer array of height of length n. So this is my array, okay, and the one heights are given. There are n vertical lines drawn such that two endpoints of ith line are I comma 0 and I comma height of I. So these are my n lines. Here you can see these are array heights of in my array. These are my heights here represented. Okay. So now two endpoints of one vertical line. It's like this one. So this is my zeroth height and this is my height h of I. Okay. Similarly, this is 0. This is h of I. Basically height of the, you can say, container or vertical lines. Find the two lines that together with the x-axis. So here you can see this is x-axis together with an x-axis making an container such that the container contains the most water. So here you can see these two lines, vertical lines, are making a container and container has the maximum water. Notice that you may not slant the container. So we want the container should be 90-degree vertical. Okay, there won't be any slant height. And here you can see in example one, this is my array with these vertical lines. So these are the two length, or I will say height, that I can take data forming container, and the difference between the distance here, that is 7, and water level is also 7. So that's why the output is 49. Similarly, example 2, we have two containers of 1 and the distance between them will also be 1. So the output is 1. So now let's quickly understand how we can solve this question, okay, and understand how we will get the area. So let me quickly draw the container and all these vertical lines. So now let's check. Here you can see I have created this array, and this array basically here represents as the vertical lines, array elements, and here I will get the maximum container. So here you can see if I basically pour water here, okay, so this is also, you can say, like here also water is collected, this will be the height, but this will not be the most water, like maximum water is stored. So if I check, so the maximum water that will stored, maybe you were thinking that this will be your maximum water level, okay, but if you calculate the area, this will be come as the maximum height. Okay, so here you will get the maximum height, because here the length, you will say the length is decreased here, so it won't be the maximum height, and we will check it. So let me just clear some of the few things so that you will get the problem statement more clearly. So when I'm talking about the water container, right, water storage, it's basically a volume, right? So volume, it's length into breadth into height. But you can assume that in breadth, right, we are talking about most of the area. Okay, we are not talking about the complete volume. We can assume that the breadth, this third angle, okay, you can assume that this is of 1 unit. Okay, so if suppose you are taking this breadth as in 1 unit, so the complete volume will be of length into height. Okay, this is, we can assume as of now, because it is also saying like we only depends on the area of the container. Okay, so we just need to check length and height of the container. So you can assume that this is the length the container and this will be the height of the container. Okay, now here one question can be arise. So these are the basic elements, array elements, like 1, then this is 8, this is 6, 2, 5, 4, 8, 3 and 7. So okay, maybe I have forgot the 3. Let me quickly create it. It won't take too much time. So just add 3 here. So this is 3, this is 7. So these are the array elements, and the distance between the array elements is of 1 unit. So all these are of 1 unit. So if I want to create like I want to calculate the length, I can simply basically uh, take the difference of these two elements or take the difference of the indexes. Here you can also see the difference is 1. Okay, so that nearly basically the same. So if I will take the difference of these two, that is 8 minus 1, so it will be come to be out as 7. Okay, so here the maximum water length will be 7. Okay, so let me write length will be index of 7 minus index of 8, that is 8 minus 1, that is as 7. So length we have calculated, and we have height here, that is also 7, because see, water level will be at the minimum height of the vertical lines. So there are two vertical lines. If I calculate, this is one vertical line and this is one vertical line. So whichever is the minimum, the water level will be at that level, because like if I go above, the water level will be spread out from here. So water level will be the minimum of these two. So 8 and 7, so minimum is 7. So that's why we are getting 49 as an answer. Okay. Now let's check how we can calculate this, how we can come up with any idea, any approach that works here. So let's think of the first one, brute force approach. So let me quickly copy this. So one of the approach that can be brute force approach that can come to anyone minds is basically we will find out all the possible containers. So suppose I am taking this height and I am assuming this height, right? So what will be the possible container? This will be my possible container. So I will calculate the water. Okay. And now suppose I shift from here to here. Then again still the water level will be different. Yeah, but the height of the water will be same. Then again I move to this. Again the water level will be same. And I will move to this one. Again the water level will be like length is increasing but height is same, right? Similarly this way. And after this I will take this as an base height, and again I will calculate between these two. So suppose if I am taking this one, calculating this in this one, so this will be one of the water container. Then I will move again, then the water level will be this one. Okay, so this is one approach that we can apply, and that will be a brute force approach here. But again, the good part of brute force approach is we will definitely get an answer here. Okay, so again here what we can do, we can take one pointer here, maybe ith pointer. We can start one loop and we can simply move out j from g I plus 1 to the last element. Okay, so one can be, I will start from I is equals to 0 to n, and then I will start j is equals to I plus 1 to n, right? And then basically I will take the height, maybe like if I calculate as height will be of minimum of, let's take height will be minimum of h of I and h of g. I will get the height and height of the water. Then I will get breadth is basically j minus I, and so I got height and breadth. Then I will calculate the maximum area. So maximum area basically it will be HB and whatever the area that we have previously calculated. So in this way we can solve this question. Okay, but that will again be a brute force. And the time complexity, if I talk about the time complexity, so here the time complexity is we go of n square, because this is also learning for n times, and this will also like one of similarly nearly to n times. So the time complexity we go of n square, and we are not taking any space, so the space complexity will be constant, that will be big of 1. Okay, now if we talk about if we can optimize it, right, here we are checking each and every container possible here. Okay, and by which we are calculating the height and breadth of it. If we can optimize it a little bit, so what we can do here, so let me create it again. So now let's see how we can optimize this. So one of the approach we can consider is, like, let's try we can take 2 pointers here. Like I will start 1 pointer here and 1 pointer here. And what is the area that I am getting currently is this much area, right? This will be the maximum water height. Okay. And this will be my container area of it. So basically length, how I will calculate the length. If I'm taking 2 pointers, let's suppose L and R. So again, R minus L will be my breadth, and if I talk about height, height will be minimum of, okay, so H of L comma H of R. Okay. So this is how my area will be calculated. Now let's see how we can get the solution, how we can get our solution. Okay, now let's see how we can collect here for maximum water. So here we can move the pointers in 2 direction. Okay, there is one possibility of L plus plus and R minus minus. Okay, so if I am moving my this pointer R, okay, tell me first of all, what is the area? The area is some constant K. Okay, right now let's assume. But if I am moving my R pointer, will the area will decrease? Right, suppose if R is here, my area will decrease because the length will decrease. Okay, so R minus L, R pointer will decrease, so my R pointer will decrease, so the difference will decrease. Maybe the height will be same because minimum of HL, so this is this one, but area will decrease. Okay, so this is complete sure that if I am changing that pointer or that pointer height, so suppose this is certain height, okay, and if I am moving this one, this is not affecting. Why? Because this height here, the height is not responsible for the water height. Water height, so here you can see my water height is dependent on the minimum one, and which is the minimum one? That is the L. So my water height is dependent on this one. So no matter if I am changing from here to there, my water content, my area will going to be decreased for sure. That is completely sure that if I am moving in this direction, it is going to be decreased. So the only possibility is that I can get a maximum area. That is when I am moving that height or when I am moving that pointer, that height is responsible for the water content. So here this pointer height is responsible for the water content. I will move this one, not this one. So suppose if I am moving my L pointer here, now what is the height? Now this is the height. This is the height. Okay. So I will get this much water. Okay. Now which pointer's height is responsible? This pointer height is responsible. So again here, if I am moving L pointer here, no matter what, my area will always decrease because this height is responsible for water height. Okay. So if I am moving my L pointer, it won't change anything. Okay. But if I am moving my R pointer, there is a possibility that we can get a maximum area or we can get a minimum area as well. But there is a possibility there will be an effect on the water if I move the R pointer. I hope you got it. So here we have two heights, H and L and H and R. What I am trying to say, okay, from these two heights, which one is responsible for water level, I will say. responsible for water level, because water level will define the whole container. So which one responsible? That the minimum one. Okay, minimum of HL and R. Now if minimum is responsible for it, what we will do? We will try to change the minimum. We will try to change the minimum, and in this manner we will get the maximum height. Okay, so let's try to do it. So I will quickly copy this one, paste it here. Okay, and now let's see. So let me quickly copy this. Sorry, let me quickly copy this height to paste it here. And now let's quickly solve it. So here again, so these are my indexes. Let me quickly add these indexes: 4, 5, 6, 7 and 8. Okay, and so what I will do, I will again I'll take one L pointer 0, and I will take R pointer as n minus 1, that is the total length minus 1. So L pointer and R pointer, and I will calculate the area. So area basically again it will be length to height of the water level, or I will say height of water level. Now length will be R minus the L pointer. This is length, it's not the L pointer here. This is length. Okay, R minus L will be responsible for length, and height of the water will be minimum of HL comma HR. Okay, now once we calculated the area, we will write one condition. Basically, if HL, that height of level L, lower than H of R, what we will do? We will move the L pointer. Okay, because this is responsible for water level, so we will try to move this one. Okay, else we will move R pointer. So now let's quickly try it, is this is working or not. So here we have an L pointer, we have an R pointer. Okay, and let's calculate. So here this is the water level. Okay, so if I calculate the area here, what is the area that I am getting right now is 1 into 8 minus 0, that is 8. I am getting 8. Now again what I will do, again this is responsible for my water level, so I will move this one. Okay, now what is the area? The new area will be, this will be my height 7. Okay, and the difference between 8 minus 1, that is also 7, so new area will be 49. Okay, now this is responsible, like this height 7 responsible for it, so what I will do, I will move my L pointer. Okay, and now the new area that I will get is this one. Okay, so now what will be the height? That is 3 into 7 minus 1, that is 6. So that will be 21, which is not greater than 49. Okay, so we will cancel out. Again, this height is responsible for water level. I will move this one again. Now if I am moving this one, what will be the my water level height? So this will be my water level height. Okay, so 8 into, what is the difference? 6 minus 1, that is 5. So 8, 5, 40. Again 40 is less than 49. Okay, so that we will again not update our area. Now again, which is responsible? Any one of them is responsible, right? So we can move L pointer or R pointer. Let's try, suppose if we are moving L pointer. Okay, so now what will be the height? This will be the height if I am moving L pointer. Okay, so this is 6, height is 6, and the difference between 6 and 2, that will be 4. So 6, 4, 24, which is again not greater than 49. And now again, which is responsible for the water content? Again 6 is responsible, so I will move this one. And now what is the height possible? It is this much height. It is 2 into 6 minus 3. 2 into 3, that is 6, again which is lesser than 49. Again I will move, this height is responsible for water level, so I will move this one. How much I will get? I will get 5 into 6 minus 4, that is 2. So again I will 10, which is again not greater. Again this is responsible, so I will move this one from here to here. I will get this much height, and what is the area I am getting? 4 into 1, that is 4, again which is not greater than 49. So 49 is the maximum area. Now you can see here, during this we always getting the maximum possibility here when we are moving. So suppose we are taking two poles here, we are getting this much height, then we are moving this pointer here, then we are getting this much height. Again this is a maximum possibility. So here by doing this we are getting maximum areas here. Okay, and again both L pointer and R pointer moving in the same direction, though the maximum things that they can achieve, it's basically it's of order of n. Okay, it is depending on the size of the array. So again the time complexity will be order of n. We are not taking space, so space complexity will be constant. Now let's quickly check it out how we can write the code for it, and then I will show you the dry run of my code. Okay, so let's quickly move to the code part. So this is done for this video. For the code implementation, you can check out the next video.